Hi, welcome to Complete Course in Calculus. So in this section, we'll define what the derivative is, and then we'll see some notations that we are using for derivative, and then we'll see some examples. So what is derivative means? Derivative means if you have a function f, if the limit of f at x plus delta x minus f of x over delta x as delta x goes to 0. So you have a function f. If the limit of this difference quotient, the limit of f at x plus delta x minus f of x over delta x as delta x goes to 0, if this limit exists, we will denote this limit by f prime at x, and we call it the derivative of f at x, the derivative of f at x. That is what derivative means. Derivative is nothing but a limit. Okay, so it's a concept which is the limit of the difference quotient. So if this limit exists, then we will denote, this is notation. Okay, notation, the derived function. We are deriving another function which I called it f prime at x using the limit of the difference quotient. So if this limit exists, we denote it by what? F prime at x, and we call it the derivative of f at x. And by the way, if this limit exists, the limit of the difference quotient exists, we say that f is differentiable. F is differentiable. So when I say f is differentiable, it means the derivative exists. It means the limit of the difference quotient exists. That's what it means. Okay. Okay. What are the different notations that we'll be using for derivative? We'll use this notation, f prime at x. That is one notation. Or we use dy by dx. By the way, there is no any division here. It's not like dividing. Okay. This indicates y is the dependent variable and x is the independent variable. That's what it means. The derivative of the dependent variable with respect to the independent variable. That's what it means. Or we use y prime, just like f prime, or we use d by dx of f of x, or in differential equation course, we use dx y, capital D. Okay, so all mean the same thing. Okay, so the process of finding a derivative, let's say, for example, if I say find f prime at x, where f of x equal to 7, for example. For this function, we want to find the derivative. So find the derivative means what? Find the limit of the difference quotient, if it exists. So the process of finding derivative is called differentiation. So differentiation means what? The process of finding derivative. Differentiable means what? The derivative exists. Okay, let's see this example. So here you can see that derivative is nothing but the limit of the difference quotient. So let's do that. Okay, you want to find the derivative. So this is the limit of f of x plus delta x minus f of x divided by delta x as delta x goes to what? 0. If this limit exists, then that will be the derivative. Okay, limit of, what is the function? It's a constant function, right? F of x is 7. No matter what x is, always the output is what? 7. So what is f at x plus delta x? Because it's constant, it will be 7. Minus, what is f at x? Still constant, 7. Delta x goes to what? 0. So this gives you 7 minus 7 is 0 over delta x. Remember, I'm not evaluating the limit. I'm just simplifying the difference quotient. That's it. This is what we call a difference quotient, right? So this is 0 divided by delta. Delta x is not 0. Delta x is sufficiently close to 0. So don't think like, oh, this is 0, this is 0, 0 over 0. No, it's not 0 over 0. Okay, the denominator is not 0. The denominator is sufficiently close to 0. So 0 divided by very small number, no matter what this guy is, first, even before you evaluate the limit, this will be 0. So delta x goes to 0. So what is the limit of a constant? The constant itself. So the answer is the derivative of any constant function, not only f of x equal to 7, the derivative of any constant function is what? 0. So the derived function, the new function which is derived using the limit of the difference quotient will be what? 0. So this is one very important basic property of derivative, which says the derivative of any constant is 0. Okay, let's see another example. How about the derivative of f of x equal to x, an identity function? So what will be the derivative? Okay, so I'm going to use same thing. I would say f prime at x is the limit of f of x plus delta x minus f of x divided by delta x. Delta x goes to what? 0. So this is the limit of what is f at x plus delta x. Now it is not constant. This is f at x is x. Whatever the input, it will be the output. So this will be x plus delta x minus f at x will be x divided by delta x. Delta x goes to what? 0. So this will give me limit of x cancels out. Delta x divided by delta x. Again, keep in mind, delta x is not 0. Delta x is sufficiently close to 0. So delta x over delta x can be simplified to 1. Now, again, limit of a constant is limit of 1. As delta x goes to 0, there is no any delta x here. So it will be 1. So what that means? The derivative of f of x equal to x is what? 1. Okay. Another example. I would say f of x equal to radical x. Okay, I want to find the derivative of f of x equal to radical x. So I'll be using same thing, the definition. F prime at x is what? The limit of f of x plus delta x minus f of x divided by delta x. Delta x goes to what? 0. So that will be limit of f at x plus delta x will be what? X radical of x plus delta x minus radical x divided by delta x. Delta x goes to 0. So what I did here is f at x is radical of the input. So f at x plus delta x will be what? Radical of the input, because the input is x plus delta x. F of x I just copied here minus delta x. Now, how do you find the limit of this? So if you remember in the previous videos, we did a similar example. So if you want to find limit of an expression involving radical, you have to rationalize. In this case, we are going to rationalize the numerator. So rationalize the numerator means what? You multiply by the conjugate. So let's do that. X plus delta x minus radical x times radical x plus delta x plus, that's what the conjugate is, radical x divided by, let me clear this so that you guys are not okay. Radical x. So this is delta x times radical of x plus delta x plus radical x. So basically what I did is I multiplied both the numerator and the denominator by the conjugate of this expression here. So as delta x goes to 0. Now, if you FOIL this guy, radical of x plus delta x times radical x plus delta x, that will give you x plus delta x. Then the next guy becomes radical x times radical of x plus delta x. This with this becomes minus radical x plus delta x radical x minus x over delta x times radical of x plus delta x plus radical x as delta x goes to 0. All right, now you can see that these two terms cancel out, the x cancels out. So what's left? Delta x in the numerator, delta x times radical of x plus delta x plus radical x as delta x goes to 0. Now delta x also cancels out. So limit of 1 over radical x plus delta x plus radical x as delta x goes to 0. Now I can evaluate. So if you plug delta x to be 0, that will give me what? Radical of 1 over radical of x plus radical x. So radical x plus radical x is what? 2 radical x. So the derivative of radical x becomes what? 1 over 2 radical x. Thank you for listening. I'll see you in the next video.